Remember those chemistry textbooks from school? All those rules that seemed totally set in stone? Well, what if I told you that in labs right now, scientists are treating that rule book more like a set of suggestions? Yeah, that's literally what's happening. We're in a time where the fundamental principles we all had to memorize are being stretched, twisted, and sometimes completely ignored, all to create molecules that we once thought were, well, impossible. So before we can really appreciate how they're breaking the rules, we gotta understand what those rules are in the first place. All right, so let's rewind a bit. Chemistry didn't just pop into existence. It's got this super long, fascinating backstory that really sets the stage for where we are right now. At its core, chemistry is the science of, well, stuff. Everything. There's a reason it's called the central science. Think of it as the ultimate bridge. It connects the tiny, weird world of physics with the big, complex systems of biology, geology, and medicine. It's the how behind a plant making food from sunlight, or how a pill knows exactly where to go in your body. And man, what a journey it's been. It all started way back with alchemy. You know, that mix of magic and science trying to turn lead into gold. Then you get guys like Antoine Lavoisier, who came in and said, okay, let's actually measure things. And boom, he gives us a foundational law. Matter isn't created or destroyed. Fast forward to the 20th century, and quantum mechanics just blows the doors off everything, giving us this wild new picture of the atom. All of that history built the foundation we're standing on today. So what are these so-called rules? Well, they're basically the instruction manual for the universe. They dictate how everything is put together, from the device in your hand to the very air you're breathing right now. Everything, and I mean everything, starts with the atom. You've got this tiny, dense core in the middle, the nucleus, packed with positive protons and neutral neutrons. And then, zooming all around it, you have this cloud of negative electrons. That's it. That simple little setup is the Lego brick for every single element we know of. But here's the thing, atoms almost never fly solo. You could say they're pretty social. They love to link up with each other using what we call chemical bonds, forming molecules and compounds. A molecule is like the smallest possible bit of a substance that's still that substance. A single molecule of water, H2O, right? If you take away one of those atoms, poof, it's not water anymore. These bonds are literally the glue that holds our entire world together. Now, for ages, one of the go-to rules for predicting how these atoms will hook up has been the octet rule. It's actually pretty simple. Atoms just want to be stable. They want to be happy. And for most of them, happy means having 8 electrons in their outermost shell. So they'll do whatever it takes, share them, steal them, give them away, just to hit that magic number 8. It's been an amazing guideline, but as we're about to see, it's definitely not unbreakable. Okay, and this is where things get wild, because right now, chemists are in their labs intentionally building molecules that completely defy these classic rules. They're twisting them, straining them, and opening up a whole new world of chemistry. Okay, check this out. The carbon-carbon double bond. It's like one of the most fundamental things in organic chemistry. Every textbook will tell you those atoms have to lie flat, on a single plane. It's a rule. But researchers at UCLA, they've actually managed to cram and force these bonds into these bizarre, twisted 3D cage shapes. We're talking about structures that, by all textbook logic, just shouldn't exist. The lead researcher on that project, Neil Garg, said it best. He said, "It turns out almost all of these rules should be treated more like guidelines." And that quote, that just nails it. It perfectly captures this new way of thinking. It's not about throwing the old rules away, not at all. It's about realizing they're way more flexible than anyone ever thought. So what do we even call these things? The official name is hyperpyramidalized alkenes. Yeah, it's a mouthful, I know. But here's the gist. In a molecule like cubene, the bonds are under so much stress, they're so twisted out of shape, that they're not really a double bond anymore. But they're not a single bond either. They're stuck in this weird in-between state. It's basically a whole new kind of chemical bond that we're just starting to understand. But okay, why bother? Why go through all the trouble to make these impossible molecules? Well, it turns out it's a huge deal for medicine. See, modern drug design is all about shape. You're trying to build a molecule that fits perfectly into a target in the body, kind of like a key fitting into a very specific lock. By creating these new, super rigid and totally weird 3D shapes, scientists are essentially forging a whole new set of keys that nobody has ever had before. And it's not just medicine that's getting a shakeup. This whole rule-breaking mindset is also tackling one of our biggest challenges, building better batteries. We're literally building the future, atom by atom. Let's be real, we all want better batteries, right? Ones that are safer, last way longer, and charge in a snap. And for a long time, solid-state lithium batteries have been seen as the next big thing, the holy grail. But they've always had this one killer weakness. The material inside that keeps the positive and negative sides from touching, the electrolyte, is super brittle. And with use, it develops these tiny cracks, and eventually, the whole battery just dies. So researchers at Stanford came up with this incredibly clever, almost elegant solution. They took an unbelievably thin layer of silver. We're talking just 3 nanometers thick. To put that in perspective, that's thousands of times thinner than a single strand of your hair. They coated the brittle material with it, and then they heated it up. What happens is the silver atoms actually wiggle their way into the surface, swapping places with some of the lithium atoms. It's just this tiny atomic-level tweak, but it has this huge, massive effect. Just how massive? Well, the new material was 5 times more resistant to those cracks. 5! That's a game changer. This tiny bit of atomic engineering might just be the key that finally makes these next-gen batteries tough enough for the real world, powering everything from our phones to our cars. So the big picture here is pretty clear. The future of chemistry isn't some far-off idea. It's happening right now. By having the courage to question the old rules, scientists are designing brand new medicines, they're building safer and better batteries, and they're discovering chemical reactions we literally didn't even know could exist. But, even as we're rewriting this scientific rulebook, there are some rules that are absolutely non-negotiable. All of this incredible mind-bending work, it's still built on a rock-solid foundation of safety. Because, hey, breaking the rules of bonding is one thing, but you never, ever break the rules of lab safety. So, yeah, the textbook is no longer the last word on the subject. It's more like the first chapter. Every single day, in labs all over the globe, new pages are being written, filled with molecules and reactions that completely defy what we thought was possible. Which really makes you wonder, right? What impossible discovery is just around the corner?